Here are gas law calculations that are going to involve a unit conversion. So as I label this 5-liter sample, that's my V1, has a pressure of 107 kilopascals is my P1, and a temperature of -5 degrees, that's my T1, add 273 to change it to Kelvin. If the temperature is raised, so here's T2, add 273 to turn it into Kelvin, and has a new pressure, there's my P2, what will be the new volume? What is V2 is what I'm solving for. Now what makes this an issue is that my pressure units don't match. One is in kilopascals, one is in atmospheres, so I'm going to have to change one of them to match the other one. It really doesn't matter which one, take your pick. I'm going to go ahead and just take the kilopascals and change them to atmospheres. So I'm going to say 107 kilopascals, put it over 1, times, draw a line, bring down kilopascals, and I want to change that to atmospheres. I'm going to look here, 1 atmosphere is equal to 101.3 kilopascals, 101.3 kilopascals, and then whenever I do this math in the calculator, I'm going to get 1.05 or 1.06, so 1.06 atmospheres. So I just did 107, and it's times 1 divided by 101.3. Now this 1.06 atmospheres is going to be my P1 instead of the 107 kilopascals. Here's my equation, so I'm going to put P1 1.06 times V1, which is 5.00 liters, over T1, 273 minus 5 is going to give me 268 equals my P2 is 1.79. I don't know my V2, and my T2 is 40 plus 273, which is 313 Kelvin. So now that I have my equation set up, remember we're going to start our multiplication across this way. Don't ever start multiplying across your variable. So 1.06 times 5.00 times 313 divided by 268 divided by 1.79. I'm dividing by the variables associated with my V2. So now I can type this into my calculator. It's going to go 1.06 times 5.00 times 313 divided by 268 divided by 1.79, and we get this. I have 3 sig figs mostly across the board there, so my final answer is going to be 3.46. V2 equals 3.46. Whatever unit my V1 is, which is liters, is the unit of my V2. One more example. A gas occupies 12.3 liters. That's my volume 1. At a pressure of 90.5 kilopascals, there's my P1. What is the volume? So I'm looking for V2 when the pressure is increased to, so here's my new pressure, 840 torr at constant temperature. So I do have to consider that my pressure units don't match, and I have to convert one of them to match the other. So I'm going to take this one and I'm going to change it to torr. And so I want to know how much is that in torr instead. So we'll take 90.5 kilopascals, put it over 1, times, draw a line, bring down kilopascals, and go straight to torr. And then we're going to look at our conversions to see that it is 101.3 kilopascals is equal to 760 torr. So when I type this into my calculator, I'm going to type 90.5 times 760 divided by 101.3, and that is going to get me 679 torr. So that means up here 90.5 kilopascals is the same as 679 torr, and now both of my pressure units match one another. Now notice that temperature was constant, so my original equation P1 V1 over T1 equals P2 V2 over T2. I don't need temperature because it's constant, so now I'm going to plug in my variables. P1 is 679 times V1, which is 12.3, equals P2 is 840. What is V2? And that's what I'm solving for. So what I'm going to do is start on the side that does not have V2. It's 679 times 12.3, and then this number over here with the V2 is going to be divided by. So this is just basic algebra. I'm just kind of shortcutting the algebra, but in class, if you need to know, we can go over why can we do it this way. 679 times 12.3, and then it's going to be divided by 840, and that's going to give me an answer of 9.94. Actually, that's 2 sig figs, so we'll go with 9.9. And so V2 equals 9.9, and then whatever the volume of V1, which is liters, is telling me the volume, that is V2. We have a couple of questions over here on the right that I want to answer. So which variable is constant? The temperature is constant. Describe what is happening. So notice pressure 1 is at 679, and then pressure 2 is at 840. So the pressure is rising. And then let's look at our volumes. It started as 12.3 and ended at 9.9. So the volume went down from 12.3 to 9.9. So this is an inverse relationship that you can see. Now, what does the graph look like of this inverse relationship? So if I were to draw the graph, it would be a curve with pressure and volume on my axes. And then finally, explain why this change occurs. Well, as you decrease the volume, you have a smaller space, right? Decreasing the volume is going to create a smaller space, which means you're going to have more collisions with the container walls than you would in here because they have further to travel, right? So because there is a shorter distance to travel, there are going to be more collisions with the container walls. So when you decrease the volume, you have a smaller space, which means there's a shorter distance for the particles to move, so they're going to collide with the walls more often in the container, which means we're going to have an increase in pressure. So decrease volume, increase pressure.